urinary tract infection, or in short, UTI. The solution using CRISPR technology. Let's pretend we have a little city inside our bodies, just like a busy town on a weekday morning. In the city, all the people work together to make things happen. Now let's pretend that instead of people, there are tiny creatures called microbes. The community of all the microbes together called microbiota. Most of the creatures in the community are good, and a little part of it might not be so friendly to the body. But, in a healthy body, they all get along just fine and are working together just like people living in a big city. The microbiota appears in different parts of our body, and among them in the urinary tract. When the urinary tract troublemaker, pathogenic E. coli, comes to visit, it meets all the creatures who already live there. A group of creatures from the community, called Lactobacillus, are good bacteria that keep the urinary tract region healthy and safe from bad and pathogenic creatures like pathogenic E. coli. Our team gathered all this information, like pieces of a puzzle, and came up with a new idea for treating UTI. Meet our hero. Lactobacillus crispatus. This is a bacteria that belongs to the good guys. It's like a friendly guest in our body, not causing any trouble and even helping out. But just having Lactobacillus crispatus wasn't enough. We wanted to make it even stronger, and give it an extra weapon against E. coli. With an understanding of how E. coli turns into a troublemaker and hurts the body, we aim to make crispatus produce the same Fim-H protein which the E. coli uses to stick the epithelial cells and cause the troubles. That's how we'll make Lactobacillus crispatus our superhero, that will fight off E. coli. But how do we make Lactobacillus crispatus do something it doesn't naturally do? For that we are planning to use a little bit of magic called synthetic biology. By using CRISPR technology from the toolbox of synthetic biology, we aim to modify the genome of Lactobacillus crispatus, giving it a new ability that will be a lasting change. But first, what is CRISPR? CRISPR technology is a cool genetic tool that allows scientists to add, remove or adjust specific parts in a living creature genome. This is with the help of two team members, guide RNA and Cas protein. Guide RNA is like a GPS telling Cas protein where to cut. It guides Cas protein to the exact spot in the DNA where you want to make the change. Cas protein is like a pair of scissors. It's good in cutting DNA. Guide RNA and the Cas protein are naturally served as a defense system in a creature called archaea, and some groups of bacteria. But nowadays, scientists can create their own custom guide RNA, targeting it to specific gene they want to change. When combined, Cas protein and guide RNA act like a pair of scissors in a map. The combination of those two enables scientists to carefully cut and edit specific sections of the genetic code. When the DNA is cut, it leaves a little gap in the genome which the cell tries to fix. Sometimes it makes mistakes. By customizing the guide RNA, scientists can decide what kind of changes to make. They can turn off a gene, fix it if it's broken, or even put in a brand new piece to the genome. That way, we are aiming to add the Fim-H gene to our Lactobacillus crispatus. By doing this, we set up a contest between E. coli and our friendly Lactobacillus crispatus. They will race to see who can grab a spot on the receptor first. Our goal is to ensure there's no space left for E. coli to attach, causing it to be carried away by the urine. This way, we will ensure Lactobacillus crispatus wins, and E. coli is out of the game. And give women around the world their quality of life back. Hearing them say, bye-bye to UTI.